Okay, so the first thing that I quickly want to discuss is the basic theory behind strike lines. So you all know that if you've got a rock body, okay, let's call it a tabular rock body like this, okay, and you have to indicate the strike on this. Of course, the strike will be something like this, okay. I know it's very skew, but my point is that this has got 0 degrees of dip. So in something that is horizontal like this, any possible direction over that surface, okay, will have a 0 degree dip, and that will always be a strike, okay. So strike is direction of 0 degrees dip. So if you've got a tabular rock body which is now plunging at a specific angle, that's the horizontal again, okay. So that is again 0 degrees dip, and of course at 90 degrees to that, okay, that will be 90 degrees, you will have your maximum dip, which is going to be your dip direction, okay. So don't be confused, the dip direction also have a 0 degree dip, but associated with it is a dip angle, okay. So that refers to the horizontal. So a dip direction, okay, is a direction, but it's got a dip angle associated with it. That is one of the reasons why you can use dip direction as well as strike to indicate the orientation of a rock body. But then of course you always have to add your dip angle, and you would remember that your dip direction is at 90 degrees to your strike. Okay, so that is the first part that you always need to remember. So what does it mean? And I'm going to try and draw this a little bit better now. I'm not always very good at sketches, especially if I have to look past the camera to do this. Okay, if you've got a rock body, okay, and we call this a rock body, and we are only seeing certain parts of that rock body because of erosion and so forth, and this here actually represents now, this represents, let's call it 250 meters. It means that everywhere on this rock body where it cross-cuts the 250 meter contour line, okay, it will be at the same elevation, and therefore because it's at the same elevation, it will of course have a 0 degree dip from one point to the next point, okay, all along that same specific elevation. If you've got a different elevation here, okay, and you call this 200 meters, of course everywhere there, this rock body will also, at those specific points, be at 200 meters. Therefore there's going to be 0 dip from here to here, and that is in a sense what strike lines mean. Strike lines means that you will connect certain parts of a rock body, okay, where they are always at the same elevation. And how do we know this on a topographic map? Well, it's actually very simple, because if you've got contour lines, okay, let's just be very simple about this. We've got contour lines, we call this 200 meters, this is 250 meters, contour lines on the map, and we've got a rock body, okay, and the rock body is doing this. It means that at this point here and at that point there, the rock body, or that part of the rock body, is at the same elevation. At this point here and at this point here, those two parts of the rock body is at the same elevation. The same applies to this point here and this point here. They are at the same elevation, and of course there's a small little bit there and there that is also at the same elevation. So what you can do is you can connect those points at the same elevation, and that forms a strike line. Okay, can you guys see that? It means it's a line of strike, meaning you connect parts of the rock body which is exactly the same elevation. Now you would see that I'm looking here at the contacts, because remember there should be another rock type here, sorry for using the black there, and there should be another rock type here, okay. Within the rock body itself, it would be very difficult to know where you are, okay, whether you're looking at the same part of the rock body. But the best place to do this, especially in sedimentary rocks, the layers sort of like, they tend to stay very similar in thickness from one point to another point. So therefore we look at the actual contacts, okay, because a contact between one rock body and another rock body can easily be recognized in the field. The thing though is, when you draw in these strike lines, and let me just draw some contour lines here again, call it 250 meters, okay, this is 200 meters, those are contour lines, and we've got a rock body, which color shall we use, and let's say our rock body does this, okay. There are two contacts here. We can refer to this as an upper contact and a lower contact, okay. That of course depends on the young directions in the rocks itself. But when you do use a map, okay, as you will see later on, and you actually have to draw in these strike lines, it is very important to work with one contact at a time. So we can draw in the strike lines for the lower contact. That is, be connecting this point and that point. So therefore there will be a strike line. That's the lower contact, this point, that point, same elevation, and that will be a strike line. Those are two strike lines for the lower contact. You can of course also go and do the same for the upper contact. You will see in this case that for the upper contact we've got a point here and a point there where the contact is the same elevation, and therefore you can draw in a strike line. But you will also see that the upper contact, okay, intersects there, and this strike line then coincides with that of the lower contact. So it's very important, as you will see, when you draw your cross sections, to work with one contact at a time. One contact at a time, drawing the contacts for one contact at a time when you do your cross sections. Otherwise your map is going to become very cluttered and very confused, and you will be totally lost. Now that is a very basic overview of strike lines. Just remember that strike lines coincide with the strike direction. Therefore, when you've got strike lines on the map, you can also of course go and determine the direction. Okay, so for instance, if you've got a map here which is north, and we've got a series of strike lines here, if you want to know the orientation of the strike of this rock body, you can basically go and measure the angle, okay, that will be the orientation of strike, okay, and then you would know, depending on which direction the rocks are dipping, you will see that later, rocks are dipping in that direction, this will be dip direction, which is at 90 degrees away from the strike. Okay.